Hello, I'm David Brown from the Solidworks training team. This video presents a project that you can use to hone your X-Design or SolidWorks skills and is easy to make if you have a basic 3D printer. Bridges are a vital part of a society's infrastructure as they connect communities, enable the efficient movement of people and goods, and support economic development by linking key transportation routes. The key aspects of this design that I will focus on are design intent, assembly, component features, exporting solid bodies, and 3D printing. Let's get started. This bridge design is made up of only 6 unique components using basic CAD techniques, making it ideal for beginners. Once printed, the components snap together easily and require no adhesives or fasteners. Designed for 3D printer optimization, the components adhere to flat pack design principles. This makes it a sustainable design. Minimizing support material means low cost. I would like to start by showing how the model is put together in the X-Design assembly. In the sections that follow, I will demonstrate how each individual component is designed. I started by placing a center section at the origin. This will allow me to take advantage of symmetry. I placed center sections on either side, followed by an A section at one end, which I then mirrored to the other end, using the ZX or right plane. This creates a new part titled Symmetry of Bridge A section, which can be seen in the design tree. Once one side was assembled, I used a linear pattern to create the other side. A lateral brace for the bottom and top were inserted, followed by a linear pattern for these. The lateral braces at the ends for the top and bottom are spaced a little differently due to their location on the A sections. One abutment is inserted at one end, then mirrored to the other. The decking fits snugly between the sides and is joined together with a small connector snapping into place. With the bridge assembly open in X-Design, I will click the Bridge Center section and from the context menu select Open. This will prompt me to save the assembly before closing it. I'll elect not to save it. You will notice at the bottom of the tree in the Design Manager, I have applied black medium gloss plastic as the material. To better visualize my designs, I typically like to apply the material that the component will be made of, as I'm designing. The sketch that drives the feature is simple. It is a 50mm square with the members of the section at 3.25mm wide. The contours of the sketch are then extruded 2.5mm thick. With the A section, I used 2 extrude features. The first one defines the outside of the triangle with a square section. This is extruded 2.5mm just like the center section. The second sketch defines the inner support members of the section. The important aspect of this is that the location of the left side of the square part is the center of the triangle. I added a small 3mm cut to remove the point from the side of the triangle. In the assembly, I used the resultant face to align to the side of the abutment. There are 2 types of lateral braces used in this bridge design. I called this one Lateral Brace with Snaps because it has features that allow for the bridge sections to snap into. This brace is primarily used at the bottom of the bridge. The initial sketch defines the overall size and shape of the profile, which is then extruded 2.5mm. The second sketch drives an extruded feature that adds 10mm of material to the ends. The third sketch is created in the context of the assembly. The 0.05mm value is a tolerance that works with my 3D printer, which allows for a snug fit to hold the parts together. I recommend running some test parts to realize the capabilities of your 3D printer. The cut is a depth that matches the thickness of the section components, 2.5 millimeters. The 0.05 millimeter values are external references to the section components in the assembly and are listed at the bottom of the design tree. The other lateral brace is primarily used at the top and is designed to provide lateral support and hold the top of the sections together. Only two features are required for this. The first one is the same size and shape as the lateral brace with snaps. The second feature allows for a 2.5 millimeter gap, which is the same as the thickness of the sections. The dimensional accuracy of my 3D printer is good enough that I don't need to include a tolerance for a snug fit. I use nominal values. The orientation of the parts as they are printed also maximizes the accuracy. The abutment holds the bridge up and is designed to hold the sides and decking of the bridge together. The first sketch defines the profile of the abutment, which is then extruded 12 millimeters. The second feature provides support and protrudes inward due to the forces on the truss. The height of the triangle is coincident to the underside of the abutment and extruded up to the inner vertex of the first feature. This is then mirrored to the other side. Fillets are added to dress it up a bit. The decking was created to span the length of the bridge, fit the width of the abutment with the side sections, and fit within the parameters of the 3D printer. The width takes into account the inner dimension of the abutment minus the width of the two side sections. 82 millimeters minus 5 millimeters equals 77 millimeters. An easy way to accomplish this in the CAD system is to create the decking in the context of the assembly. The decking is divided into two pieces due to the constraints of the 3D printer. The length is half of the span of the truss, with a little added to the end to overhang the abutment. This also helps to hold the structure together. The second feature is the added material that overhangs the abutment when assembled. 5 millimeters wide, extruded 5 millimeters. On the bottom of the decking is a sketch that is used to cut material for a connector to hold the two decking sections together, and a lateral brace next to the abutment. Notice the size of the cut is the same dimensions as the features of the lateral brace, and the spacing of 12 millimeters is the same thickness of the abutment. Using nominal values ensures a nice snug fit between all the components when the bridge is assembled. The depth of the cut allows for a very small clearance as the parts are snapped together. It is necessary to export the files to prepare them for 3D printing. Activate the Tools tab of the action bar and click Print 3D. For printer build envelopes, there are a few options. I used Add Printer Build Envelope to define one that matches my particular 3D printer, which I will then choose from the list. I will select the base for the printer orientation, and I can see that the part will fit within the parameters of my 3D printer. Click Export Print Format. I can save to a 3D drive on the cloud or to a file on disk, which puts it into the Downloads folder of my local machine. I will leave the file format as STL. That is the requirement of my 3D printer. There are several options under resolution. The default values for fine suit my needs. I'll select Export. Most of the components can be nested easily and require no support material. The lateral braces with snaps have small overhangs that require supports. Here, I used organic support structures, which provide an efficient use of support material and result in a very easy cleanup. This project presents a wide range of possibilities. The individual components are simple enough for beginners to learn the basics of designing with CAD, and the result is a model that can be used to explore the aspects of bridge design. It is a sustainable design that takes advantage of 3D printing technology while keeping cost and environmental impact to a minimum. Thank you for watching this video. Stay tuned to this channel for upcoming projects in the Useful SOLIDWORKS Design Projects You Can Make playlist, and if you found this content helpful, visit the site below to access more content for designing with SOLIDWORKS.